Hi guys, so today we're going to look at simplifying radicals. Now, a radical is square root. We've seen square roots, but it's square root is a special type of radical. It's a special name for a radical. Square meaning that there's two, something times itself. So whenever we're dealing with radicals, we need to keep this list in mind here. This is a list of perfect squares, a list of perfect square roots. Um, what that means is what times itself gives me this black number inside the radical one? One times one. What times itself gives me this black number of four? The blue one, two times two. So a perfect square is a number times itself. When we deal with radicals, um, you'll see later on in life that not all radicals are just something times itself. There might be three numbers, four numbers, five numbers, and so on. Um, so list of perfect squares. All these black numbers are important. They're key. We're going to try and hopefully break our numbers up that we currently have here, one of these numbers being one of these black ones. So let's see what's going on here with that. So I need to simplify this. Square root of 32. Now, I could punch it in the calculator, get some kind of decimal answer. I don't really care about that. I don't want a decimal answer. I want something exact. I want something that's actually going to be irrational. So I need to ask myself, is 32 one of our square roots over here? Well, I've got 36, which is close, but it's not 32, and then 25. 32 is not there, but it's somewhere between them. Okay, since it's not on the list, I don't have one answer, but I can break 32 up. I'm gonna say, what are two numbers multiplied together to give me 32? Now I could run down a huge list and say 1 times 32, 2 and 16, 4 and 8, 5 no, 6 no, 7 no. So here's our list. Now I'm looking for a perfect square. 4 is perfect, 16 is perfect. I've got a 4 there, I've got a 16 there. Good. I want to find the largest number, and that's going to be this pair, 2 and 16. So what I end up doing is rewriting square root of 32 into two numbers, 16 and 2, both under square root. So 32 is under the house. I'm just going to separate them, and they're still under the house. Now, the purpose of this is I can now simplify square root of 16. Square root of 16 is 4. Once you take the square root of something, the house is gone. The square root symbol is gone. Square root of 2, I can't do anything with. It's not on my list. There's nothing there. It's the smallest possible number it can be broken into. I'm going to leave it. It stays inside the house. Now, I know this can maybe look a little ugly, but that's okay. The whole point is just let's make this smaller, and we did. All right, so I have 3 times square root of 16. So square root of 16, that is one of our perfect squares. I know it's 4. So I'm going to rewrite, instead of the square root of 16, I'm going to write just 4. Now, this group right here is right next to that 3. They're touching each other. When they're touching, that means it's multiplication. So I need to multiply my two answers together now, and we get 12. All right, so that's what it looks like with numbers. What about with a variable? So with our perfect squares, what times itself gives me x squared? X times itself. What times itself gives me x to the fourth? X squared, x squared. What times itself gives me x to the sixth? X to the third, x to the third. We're basically kind of cutting that exponent in half. Now, I can't cut this exponent in half because it's a 5. We're going to be left with a decimal, and I don't want a decimal. But I can break this up into two parts like I did up here. What I'm going to split this up into is the square root of x to the fourth times the square root x to the first. And what's really happening here, now remember 16 times 2 gives me 32. X to the fourth times x to the first gives me x to the fifth because we have to add those exponents, 4 plus 1, to give you that 5. Now, I can do this. This square root of x to the fourth is on my list. I know it's a perfect square. I know my answer is x squared. Once you take that square root, you bring it down. No house. X to the first is not perfect. It's not over here. So I'm just going to rewrite it, square root of x. And you could put a 1 there, but you don't necessarily need that 1. It's an ugly answer, but it's simplified. All right, what if we happen to have more than one radical being multiplied together? This 5, it's not perfect. The 10 is not perfect. Whenever you have two radicals being multiplied together, we need to put them together. We need to multiply them together. That dot in the middle says multiply, so let's multiply. 5 times 10 gives me 50. Now my answer of square root of 50 is not one of my perfect squares. I've got 49, I got 64, but there's no 50. But I can break this up. So what I'm doing is I took two radicals, I put them together to get that radical 50. Now I want to split them up in a different pair. Well, what pair can I use? Well, we have 1 and 50, 2 and 25, 3, 4, 5 and 10, and that's it. Now, do you have a perfect square in one of these lists? Yeah, right there, 2 and 25. So what I'm going to do is rewrite this as square root of 25 times the square root of 2. Square root of 25, I know, is 5. That comes down. This square root of 2, I can't do anything with. Let's leave it. Square root of 2. We now have a whole number and a radical times a whole number and a radical. I want to put these two things together with multiplication. What we're going to multiply right here is like pieces. So I have my outside numbers. I want to multiply them first. 3 and 4 gives me 12. I then want to multiply my inside numbers together. 10 times 10 gives you 100. This square root of 100 is one of our perfect squares. We know that square root of 100 is 10. But that number of square root of 100 is touching the 12. What does that mean? It means multiplication. I still need to multiply those two things together. Take it one more step, 120. Sometimes we can have numbers and variables all under that square root, and we just take it piece by piece. We look at it as if it's a couple problems all at one time. So I want to look at this in two ways. And I'm going to break this up first. You don't have to break it up like this, but I like looking at it in two ways. Square root of 25 and square root of x squared. Square root of 25 is perfect. We look over there, we know it's a 5. We bring the 5 down, there's no house. Square root of x squared, we know it's perfect. Bring down the x, no house. These two things are next to each other, multiplying. There's nothing else I need to show. Just circle it, there's your answer. So same thing down here. We've got a number on the outside. We have a couple numbers and variables on the inside. Let's break them up. And I'm not going to split it up like I did here. I'm just going to kind of just cut out one little step here. Square root of 16, we know is a perfect square, gives us a 4. Square root of x to the fourth, we know is perfect. We know it's x squared. We no longer need the house. But both of these numbers are touching that 3, so we need to multiply. And now, let's multiply like pieces together. Just 3 times 4, 12x squared. All right. If you can do all of this, we can do these. It's just a matter of more steps, more problems all kind of combined into one. So let's start with the 28. 28 is not a perfect number. It doesn't fall over here, but can I find two numbers multiplied together to give me a 28? Well, let's run down the list. You could say 1 times 28, 2 and 14, 3 no, 4 and 7, and that's it. And do you have a perfect square in here? Yes. 4 and 7. The 4 is perfect. So instead of 28, I want to rewrite that as 2 radicals. I'm going to rewrite it as radical 4 times radical 7. And then I'm also going to bring down the x squared and the y squared as well. Now, and let's bring the 2. You now have, what, 5 terms here? Let's simplify each one as we go. The 2 comes down. We know we're being multiplied to this answer, which is going to be another 2. Square root of 7, I can't do anything yet, so I leave that. Square root of x squared, perfect square, we know is x. The square root of y squared, which is going to be taken care of just the same way as this, and we're just going to say y. Now, there's a special order we need to put these in. Usually it's always number, then variable. That's almost the case. We're going to have number, variable, radicals. So let's reorder things. So 2 times 2 gives me 4. I'm going to bring x and y up, and then I'm going to put the radical. The radical always comes last. One more. We have 2 radicals, multiple variables and numbers. Let's multiply everything together, so put it together, and then we're going to break it apart. 2 times 10 gives us 20. We used it. X times x to the 5th. Remember, you're going to have to add exponents here, which gives us x to the 6th. Now, as I go with a little more complicated problems, I like to cross off what I actually used, just to kind of simplify things in my head. Y squared and y to the 1st gives us y to the 3rd. We used it. Okay. Don't care about the black problem. Now I'm here. I need to split 20 up. What are 2 numbers multiplied together to give me 20? You could have 1 and 20, 2 and 10, 4 and 5. There's all your pairs. Are any of those perfect squares? 4 is. I like that. Here's my pair. So I'm going to split 20 up into radical 4, radical 5, radical x to the 6th, and now radical y to the 3rd, I don't like. Where was it? Back here with the x to the 5th, we split it up. We wanted one of these to be a perfect square. Y to the 3rd, I'm going to break up into y squared and y to the 1st. Now let's simplify each one. Square root of 4, 2. Square root of 5 stays put. Square root of x to the 6th is x to the 3rd. Square root of y squared is just y. And square root of y stays put. One more little thing, we got to change our order with everything. So let's put regular numbers and variables in front first. So you're going to have 2, x to the 3rd, y, we used it. And now you can combine your radicals. 5 and y. There is your answer, 2x to the 3rd, y times 5, radical 5y. And that is simplifying radicals.